then? It's going? Okay. Cool. So this course, obviously, it's going to be about advanced data analysis in general. And it's kind of centered around our new toolbox that we call the Analyzer toolbox. Formerly it was called the NIRS toolbox, but we decided that that was too generic as a name, so it became the Analyzer toolbox. So we're going to kind of center around a lot of the discussion and methods and stuff around this, but a lot of like the stuff we'll talk about it in terms of statistical models and stuff kind of extend beyond my toolbox per se. But that's where we're going to do a lot of the analysis in. And I did, just kind of as background for me, I guess I didn't give background. So I did my PhD at Harvard MGH with David Boas. My PhD was actually on multimodal imaging and combining NIRS, MEG, and fMRI to try to look at underlying the relationships between these hemodynamic and these neural signals in terms of vascular models and these wind castles and stuff like that. And so it was very much kind of multimodal imaging. And during the course of that PhD, I wrote the first NIRS software that became available to the community, which was called Homer. Since then, so now 15 years later, it's evolved into Homer 2. And then that has now sort of evolved into our somewhat competitive toolbox here, which is very much more focused on the statistics. And kind of this toolbox evolved out of, I've been here at Pitt for 10 years now, and it was working with these 27 different investigators and kind of realizing that when we initially wrote the software for Homer and were developing these methods, we were very heavy on the signal processing, the filtering, but we were physicists, we were engineers, and that's what we knew how to do. And as I kind of moved here and I started to support projects that were actually doing real science, you know, it became more of a hypothesis driven, right? We had investigators asking us, okay, well, that's great, but you know, how do I statistically test the difference between this condition and that condition? And you know, that was easy, but then the questions started to become harder, and so we started to develop these tools around that kind of hypothesis driven. And so where this evolved was, I'll switch to the next slide. So we started with this toolbox in 2014, late 2014. So it's about 3.5 years old. And the work was, I have to credit Jeff Barker, who was my former grad student, who did the initial framework for this. He did an absolute wonderful job. If you're like a computer programmer and you look at the toolbox, Jeff just did an insanely nice job with structuring the toolbox. Jeff's PhD was awesome. Unfortunately, I lost him to industry. I've lost my 2 grad students so far to industry. But Jeff worked on this. He graduated in about 2016, and he went off to industry. But I have to really credit him with this. Right now, so this is just the distribution of people that have downloaded our toolbox. You know, so we've got a large concentration on the east coast of the U.S., large concentration in Texas, apparently. Most of Europe, some of Asia, even some areas of Africa and Australia are starting to use this. So we've had about 2,000 downloads. Not that all those people are using it, and not that I haven't downloaded it several times myself. So I think it's starting to grow and pick up, and the hope is kind of as more people start to use it, and certainly that's kind of the purpose of these kind of classes like this, is it'll work both ways. I'll provide tools for you, but you'll also come back with those unique hypotheses and, oh, I really wish that I could do MVPA. Can we do MVPA within the toolbox? And so then we can go and start to think about how to develop that. And one of the themes that you'll see kind of repeated throughout here is that NIRS is different from fMRI. It's different from EEG. It has features that are common, right, in terms of, oh, it measures hemodynamic response, so does fMRI. Oh, we measure a channel space, so does EEG or MEG. We have an inverse problem. But there's really unique features of NIRS And so one of the continuing themes with this is going to be how the statistics really need to change to address those unique noise structures and features of the NIRS data. Okay, so the toolbox itself, the best place to get it is the Bitbucket site. So it's an online repository. I sent the links to this, so hopefully everyone downloaded it. If not, actually, if you have a computer and you want to try to download it, please do. If you downloaded it like not so recently, like several weeks ago or something, you can go and update your version, because we did actually make some changes based on developing these demo data sets and stuff like that. We found not anything terrible, but kind of those nuanced little tiny bugs and that we fixed a little bit. So here's the toolbox. You can go to that. It does require MATLAB 24B or newer. Everything that I'm going to show today only uses the statistics and the signal processing toolbox, but we're trying to actually work it so you don't even need those, but kind of as a bare minimum processing. It's open source, MATLAB based, it's all command line, but I'll show as we go through here, we've started to develop some graphical interfaces because we're getting more and more people using it, and they want to kind of have more of a GUI-based interface to this. And then, so we have, if you go to the Bitbucket site, there is a wiki that, admittingly, we haven't updated in a little bit, at least a year or so, but it goes through the basics of how to download, how to install, stuff like that. Also on the Bitbucket, so if you want to download it, what you do is go to the left panel here where it says download, and you click the download repository. So that will download the actual toolbox. These other data zip files, they're actually called by, there's a bunch of demo scripts that we're going to go through, and the demo scripts themselves will actually download these zip files for you, so you don't need to download them separately. If you go into the Bitbucket, there's now a fourth row here, which is called the NIRS course demo.zip, and that's the demo data that we're going to be going through this afternoon and tomorrow. So if you haven't gotten a chance to download that, I only put it up like 2 weeks ago or so, but you can download that data set as well. And we have it on a flash drive that we can bring and pass around if you don't want to download. I think it's like 350 meg or something like that. It's not small, but it's not huge. Okay. Also on the Bitbucket site, we have on the thing here that says on the left panel, it says issues. So you can use this to communicate to us any sort of problems that you encounter. I know a number of you used this actually over the last few days as you were installing and testing this, and I fixed all those bugs like that. But that actually sends an email directly to me, and I'm usually fairly quick to respond to fix these things. So that's the best way with regard to I found an error or suggestion or something like that to communicate that, is to put it through the Bitbucket site. If you have more of a scientific question, you can send it directly to me, and I'm oftentimes very busy, but just email me again because I'm happy to respond. I just don't always have time to do it. So if I forget, I'm not offended if you just keep emailing me, and I'm sorry in advance if I do that. Okay. So the Bitbucket site, if you go to that, it'll download the entire toolbox. But it's actually, Bitbucket uses what's called a CVS. It's basically a way of tracking changes within the program. And so what we recommend is that you actually use one of these CVS programs so that you can actually keep up with changes in the toolbox. And so the one to use, if this works on a Mac, but it's really nice on Windows, is this Tortoisehg program. And basically what Tortoisehg is, you go to the website, you download it, and when you first start up your repository, it'll ask you basically want to clone the NIRS toolbox from our Bitbucket site. And so you would go and you would enter in that Bitbucket URL address and then the destination where you're going to put the toolbox, and you choose clone, and it downloads it all onto your computer, just the same as if you had downloaded it directly as a zip file. Only now, once it's downloaded, what you can do is you can use the Tortoisehg program to basically keep that up to date. And so if you go and you open the Tortoisehg, it has a whole history of every change that I've made in the toolbox. So you see, for example, right here I'm on revision 633. It'll give some information about what was changed in that and actually tell you which files were changed. And then if you want to, if say at the end of this course you found a bug or something like that, or something we fixed added to the toolbox, what you would do is you can use the same program and you can pull those changes from the website where it's only updating the 1 or 2 files that I changed, and you don't have to do anything. So Bitbucket uses a 2-stage CVS, which confuses some people if they're not used to it. There's basically three levels actually, of the toolbox and the history. There's the version that exists on Bitbucket, and so that's the version that I've uploaded with all the changes. And so what you do is you first pull those changes onto your computer. So it pulls the changes, checks the website against your local version, and pulls any new files. You then have a local CVS that if you're working on this and you make any local changes, it saves all that history here. And then your working version is the one that's actually MATLAB is calling. Okay? So if you make a change that you decide kind of destroyed the toolbox or whatever, you can undo just your changes or undo some of your changes like that. So it's a 2-stage system. The thing to remember is that when you update your toolbox, you have to do 2 steps. You have to first pull the data from the website, and then you right-click on the version, so let's say 633 that you want to update to. You right-click on it and you say update, and then your MATLAB then has updated your toolbox so that MATLAB reflects that. Okay, we've had a number of people that I fixed something in Toolbox, update the latest version, and they get this step right, but they forget to do this part, and so MATLAB is still referencing a really old version, even though they have a newer version sitting on their computer. And then if you do want to start to contribute to the toolbox, we don't have very many people external to my lab that are doing this at the moment, but I'm very open to the idea. It's again a 2-stage thing where you commit any changes. You can have your local history, making sure that the program works well, several revisions, and then once it's good and stable, you can then push it onto the Bitbucket site so that everyone can have access to it. So it's again this 2-stage system. Okay, and actually in Windows, what you can do is you don't even have to launch this GUI. If you click on your NIRS Toolbox folder, you right-click on it, you have those options to pull and commit or update directly from right-clicking on the folder, which is nice in Windows. On a Mac, you have to go through this interface to do it that way if you're using Tortoisehg. But as I said, it does have, if you click on anything, it does tell you what was changed. So I added this line. So in this case, I removed this red line and I added that green line. So I changed in this case, I changed the default behavior of the load directory function if you don't give it any second arguments, as an example. Okay. And my computer is thinking. I'm running that software that's capturing my screen in the background. I might not be able to do that when we actually get to the MATLAB, because that's not, okay. All right, alrighty. I'm going to have to kill that program in the background.